So in this problem, we have to focus on the denominator. Is the denominator going to become 0 for some function, for some value of x? To do that, we set the denominator 3x minus 4 equal to 0, which would mean 3x is equal to 4. Therefore, x is equal to 4 divided by 3. So you could plug in any number in the function except 4 over 3, because if you plug in 4 over 3, you are going to get a divide by 0 error. So the domain is all values of x that are real numbers except x is equal to 4 over 3. So we set the denominator equal to 0, which is 2x plus 5 equals 0. If we solve, 2x would be equal to negative 5. To find the value of x, we divide by 2. So x is equal to negative 2 divided by 5. So you can plug in any number for x in the function, except x is equal to negative 2 over 5. So the domain here is all real numbers except x is equal to negative 2 over 5. So we want to find an x value which would make the denominator 0. So 7x plus 2 equals 0. And we want to solve for x. So 7x would be equal to negative 2. Divide by 7 on both sides, we will have negative 2 over 7. So the domain is all x values that can, or all real numbers for x, except x is equal to negative 2 over 7. So here we have a slightly complicated looking denominator, but we know something about polynomials, that polynomials can be factored. And if we can factor a polynomial, the denominator becomes easier. So 2x squared minus 14x plus 20. The first step is to identify the common factor. The common factor is 2. If I pull that out, I would have x squared minus 7x plus 10. And we've got the split up 7 or negative 7 into 2 numbers so that I get positive 10. The numbers that I can think of would be negative 2 and negative 5. This is something that you should know by now because we did a lot of problems in factoring. So I could rewrite x squared minus 7x plus 10 as x squared minus 5x minus 2x plus 10. In the first 2 terms, I can pull x out. So we will have x times x minus 5. In the last 2 terms, I can pull 2 out. I will have negative 2 times x minus 5. I have a common term of x minus 5 if I pull that out, it will leave me with x minus 2. So I have factored the denominator polynomial. Since we are able to factor the denominator polynomial, things are going to get easier for us now. So if I set x minus 5 times x minus 2 equals 0, that is exactly equivalent to saying I am going to set that denominator equal to 0 because we just factored the denominator. So the denominator and this factored form are one and the same. So if I can find the zeros for the denominator, I can find, if I find the zeros for the denominator using the factored form, I have found the zeros for the denominator itself. The 2 that I factored out doesn't matter because 2 is a number. It's never going to become 0. But another reasoning for that is all I have to worry about in the denominator is x squared minus 7x plus 10, because I can divide by 2 on both sides. So the only thing that matters is x squared minus 7x plus 10, which we have factored as x minus 5 times x minus 2. That would mean x minus 5 equals 0, x minus 2 equals 0. So the two solutions are x is equal to 5 and x is equal to 2. So the domain all real numbers except 2 and 5. So the denominator is x squared minus 8x. And we want to set that equal to 0 to determine the values of x that would make the denominator 0. So if I pull x out, I would have x minus 8. So we actually have two factors. One is x and the other one is x minus 8. So we set the first factor equal to 0. We get x is equal to 0. The second factor is x minus 8 equals 0, which would mean x is 8. So the domain is all real numbers except x is equal to 0 and 8. Are we clear? Okay.